Okay, this is the Algebra 1 final review, numbers 21 through 24. So number 21 says, an algebra textbook has a total of 1,382 pages, which is broken into two parts. The second part of the book has 60 more pages than the first part. Create a system of linear equations to represent the situation. So the first thing we always do is assign our variables. And it says that we have two parts. And then it goes on to talk about how the second one has more than the first. So I'm going to call my first part x. I'm going to call my second part y. Then I have to write two equations. So they give me two pieces of information, and sometimes it's kind of disguised. The first part says it has a total of 1,382 pages. I'm going to make that equation 1. So total usually means to add. And since we have two parts, and together they make 1,382, you add x plus y, and it gives you 1,382. The second equation is about the second part. It says the second part of the book has 64 more pages than the first part. So that's going to be my second equation. Whenever it gives you information and it says something like Wendy has, or the second part has, or the second part is, that's saying this variable, second part, equals. So the second part has y equals 64 more means add, than the first part, which is x. So y equals x plus 64. So those are my two equations for number 21. Number 22 is similar. On Monday, Joel bought 10 cups of coffee and 5 donuts at his office at the cost of $16.50. I'm going to stop right there. They already told me my two things. I have coffee and donuts. So I'm going to say C is coffee and D is donuts. So, and then it says on Monday, so I can kind of guess that my 2 days are going to be my two equations. So on Monday, he bought 10 cups of coffee, so 10C, and 5 donuts, 5D, equals $16.50. And then the question goes on to say, it turns out that the donuts were more popular than the coffee, so on Tuesday, there's my second one. He bought 5 cups of coffee and 10 donuts for this total. So on Tuesday, he bought 5 cups of coffee and 10 donuts for a total of $14.25. For number 23 and 24, we're going to solve the system of equations. Now there's two ways we can do this. We can use LinSolve on the calculator, or we can use a graph in the calculator. So for the first one, I'm going to use LinSolve. For number 23, LinSolve. So what I'm going to do is add a calculator page. Right there. It won't work in Scratchpad. Your favorite button in the calculator is Menu. So Menu, the class we're in is Algebra. And then we have 2, so it's Solve System. I have 2 equations. My variables are x and y. So I'm going to scroll down and click OK. And it looks like this funky box. What we have to do is put one equation in each box, exactly like it says. So the first one is negative y equals x minus 4. And then the bottom one is y minus 4 equals negative 3x. It's solving for x and y. I'm going to hit enter, and it tells me the solution is 0, 4. Remember, a solution for systems of equations is where they intersect. So parallel lines have no solution, intersecting lines have one solution, and coincidental lines have infinite solutions. So I could have grabbed this also. I hit delete so I can write whatever I want and choose relation. Negative y equals x minus 4. To add another line, you hit tab. This is just to make sure I did it right. Y minus 4 equals negative 3x. Enter. Then menu, analyze graph, intersection. I highlight that part where they cross.
Yay, that's what we do.
So this is my intersection. I can actually drag that so I can see it. Maybe. Well, it says 0, 4. So I got the right thing. Alright. Now I'm going to try 24. Add a graph. Again, I'm going to press delete, choose relation. I have 2x equals negative 3 minus y. Enter. Tab. Put in my second line, negative y minus 2x equals 3. Enter. Oh no, it looks like the same line. Okay, let me try using Winsolve. Maybe I just typed it wrong. Solve system, x and y. 2x equals negative 3 minus y, arrow down, negative y minus 2x equals 3, enter. Oh no, what did I do? Nothing is wrong. These are coincidental lines. That means they overlap perfectly and they have infinite solutions. Alright, that's 21 through 24. Good luck on your final, guys.